Good day everyone, you're welcome back to my YouTube channel. Today we have the following interesting integral problem. Please, if today is your first day of watching this video, please subscribe to this channel and turn on the notification bell so that you'll be notified anytime we upload new video. Today we're having this problem integral as x is going from negative infinity to positive infinity, x raised to power 2 all over x raised to power 4 plus 1 dx. Okay, remember that previously we have had a video on the introduction to beta function and gamma function, and we all know the following property, that beta of mn is equal to, the integral representation of this is integral from 0 to infinity x raised to n minus 1 all over 1 plus x, okay, raised to n plus n dx. Okay, and the another one we need to recall is that the relationship between the beta function and the gamma function, this is equal to gamma of m times gamma of n all over gamma of m plus n. Okay, another one we need to recall is the Euler reflection property. And what is this property? If 0 is less than m and m is less than 1, therefore the following equality holds, that the gamma of 1 minus m times the gamma of m is equal to pi all over sine of m pi. Okay, now we're going to use the following ideas to solve this problem. Okay, now before we continue, let us talk about even and odd functions. Okay, remember that if you have a function like this, okay, let's assume we have the following function, the function of x equal to, okay, let me say x raised to power 3. Now we all know that if we take x to be equal to negative x and this function yields a value which is in negative form, let's like this, then raised to power 3, remember this is negative 3 raised to power 3. So this is telling us that this function is odd because of this sign that comes out from here. Okay, let's think if, okay, let us consider the following one, f of x to be equal to x squared. Okay, we own that if we take the negative value of x, so we have negative x raised to power 2, and this is giving us x raised to power 2. Therefore, this function is even. So this function is even. Okay, now in the following integral, remember we have this x which have an even power, and this x here has an even power. Therefore, the whole function here is what? Even. Okay, now we're going to rewrite it using the following property, that if we have integral from negative a to positive a of f of x dx, and this function is even, therefore this integral is the same as twice when x is moving from 0 to a, f of x dx. Okay, now we're going to use the following ideas to solve this problem. Okay, now let's move to the integral problem. Now we have I equal to integral from negative infinity to positive infinity, x raised to power 2 all over x raised to power 4 plus 1 dx. Okay, since this function is even, so the integral is the same as twice when x is going from 0 to infinity, x raised to power 2 all over x raised to power 4 plus 1 dx. Okay, our major priority here is to make this function to look exactly like this integral representation of this beta function. Okay, but right here we can see that we have the same boundaries as x is going from 0 to infinity, but in the denominator we are having x to have an odd power of 1 here, but this one is having an even power of 4. So we can make a substitution by taking this x raised to power 4 equals y. Okay, now we have x raised to power 4, making the substitution equals y. We all know that x is equal to the 4th root of y. Then the x is going to be y raised to negative 3/4 all over 4 dy. Okay, now we're going to use the following substitution to solve this problem. So we are having I equal to integral from, the limit remains the same because 0 raised to power 4 is 0 and infinity raised to power 4 remains infinity. So now x raised to power 2, how do we get it? Remember that this x raised to power 4 can be rewritten as x squared. Okay, if you take root of both sides, we would get that x raised to power 2 is equal to square root of y, and square root of y is the same as y raised to power 1 all over 2. Then all over, here 1 plus y as the denominator times, remember our dx will make the substitution here. So our dx is equal to y raised to negative 3/4 all over 4 dy. Okay, right here we are proceeding. So we are going to factor out this 1 all over 4. So when we do that, remember we have 2 here, so it becomes 2 all over 4, and that is 1 all over 2, integral from 0 to infinity. Then you remember this power here is not negative. So let me tell you, what we have here is square root of y, and that is y raised to power 1 all over 2. So this might be a mistake, so it's not negative. So we're going to add the following powers, and if by so doing we have here 1 all over 2 minus 3 all over 4, and this is actually giving us what? Negative 1 all over 4. Okay, so we have here y raised to negative 1 all over 4, then all over 1 plus y, then dy. Okay, but we are not done with this. So remember, we need to make this integral to look exactly like this. So we have a power of x here to be a number, subtracting 1 from it. And what is this number? How do we get this number? So we're going to compare the power of x and the power of y here. Okay, so let us compare the power. So m minus 1 is equal to negative 1/4. So we're looking for this m is equal to negative 1/4 plus 1, and this is giving us what? 3/4. Okay, and down here, okay, let us first make the arrangement first. So we have integral from 0 to infinity. Okay, then y raised to power 3 all over 4 minus 1, that is what we have as the new power, all over 1 plus y. Then remember we have 1 as the power of this expression, 1 plus y here. So what is that which we are going to add to 3 all over 4 to give us 1? Okay, because from here we know that this m plus the n which is here is going to give us 1 here. Okay, so let us talk about when we add 3 over 4 plus 1 all over 4, and this is giving us 1. So we have here 3 all over 4 plus 1 all over 4, then dy. Okay, from here we can take our function. So we have 1 over 2, the beta of 3 all over 4, and the beta of 1 all over 4. Okay, now how do we simplify this? So this is going to be taking the relationship between the beta function and the gamma function. The beta of mn is equal to gamma of m, gamma of n all over gamma of their addition, m plus n. Okay, so right here we're having 1 over 2 times the gamma of 3 all over 4, the gamma of 1 all over 4, all over the gamma of 3 over 4 plus 1/4. So here is 1. Okay, so we have here 1 all over 2 times the gamma of 3 all over 4 and the gamma of 1 all over 4. So right here we're going to make use of the Euler reflection property, and this is gamma of 1 minus m, and the gamma of m is equal to pi all over sine. I've given this earlier, sine m pi, and this holds if 0 is less than m and m is less than 1. Okay, right here we know that 3 all over 4 is less than 1 and 1 all over 4 is less than 1. So we can make this like this: 1 over 2, the gamma of 1 over 4 times, so 3 gamma of 3 all over 4, we will write it as gamma of 1 minus 1 all over 4. Okay, and from here we have this 1 all over 2. We all know that this is what? Times pi all over sine. So if you compare this with this, so our m here is what? 1 all over 4. So we have actually pi all over 4 here. And this is equal to, remember, the sine of pi all over 4 is equal to 1 all over root 2. So if we take the inverse, so we get that is 1 all over sine of pi over 4 is equal to root 2. Okay, so we have here pi all over 2 times root 2 all over 1. By rationalizing this, so we have pi square root of 2 all over 2 multiplied by square root of 2 over square root of 2. So we are having, square root of 2 times square root of 2 here, we have 2 pi all over 2 root 2. Okay, from here, these 2 and these 2 get cancelled out. So we are left with the answer to the problem, which is pi all over square root of 2. So this is the right answer to the problem. Please, thank you for viewing, and make sure you subscribe to my YouTube channel for more interesting videos.